Hello and welcome to the channel Understanding Concepts of Physics. We are discussing about waves and today we are going to discuss only about harmonics and overtones. So this is going to be a very short video, just have to discuss or distinguish and that's it. So let's just start quickly. Subscribe the channel in case you have not done so yet and keep watching the videos from the playlist in order to understand the lectures better. So let's start with harmonics and overtones. What are these harmonics and overtones? Let's try to understand. The first point will be the definition of both harmonics and overtones. So just let's go ahead with understanding what it is. So harmonics are basically the integral multiples. So it should be like 1, 2, 3, 4, 5, 6 like that. It's integral multiples of a fundamental frequency. Now fundamental frequency is basically one of the lowest frequencies which you are able to hear in case of a musical instrument or in case if some sound is being played, which may be present or may be absent. So harmonic may be present or may be absent in a sound note. So whenever a sound note is played, either a guitar is played, either a flute is played, or any kind of a sound is played, there is some minimum frequency. There is some minimum frequency which we call as fundamental frequency, and it also has its integral multiples as well. So when these are present or they are absent, all these are called as harmonics. So let's say, okay, suppose if I have a sound which has a frequency n, then it will also have a frequency of 2n and 3n and 4n and 5n, depending upon what sound you are playing. So let's say if you are playing a guitar, in a guitar you will get all these kind of frequencies. Now, so this my first n becomes my first harmonic. So this is my first harmonic. This will become my second harmonic, this will become my third harmonic, and so on and so forth. Fourth harmonic, fifth harmonic. And the first harmonic is also called as the fundamental frequency because this is the base frequency. This is the lowest frequency which we are getting in that kind of note. Now what are overtones? Overtones also are the multiples of fundamental frequencies, but these are only those frequencies which are actually present in a note. So suppose if you are getting a sound in which you are getting n, 2n, 3n, 4n, 5n, like in case of a string, in case of a guitar, in case of a violin, then your first harmonic is never allotted a overtone number. The second harmonic will be allotted your first overtone, third harmonic will be your second overtone, fourth harmonic will be your third overtone, fifth harmonic would be your fourth overtone, and so on and so forth. So what you do is, whatever the fundamental frequencies are there and the integral multiples, they are harmonics. They are present or they are absent, it is irrelevant of that. But when it comes to overtones, the fundamental frequency and integral multiples are valid, but the sound note should be actually present. So if in a string, if you are getting a sound note of n, 2n, 3n, 4n, 5n, and so on and so forth, then your second harmonic will become your first overtone, third harmonic will become your second overtone, and so on and so forth we are going to proceed. Remember that first harmonic it never gets an overtone number. Okay, so let's just see. So harmonic is integral multiple of a fundamental frequencies which may be present or absent in a note. In an overtone number is also an integral multiple of fundamental frequencies which are actually present in a note. Now you will say, okay, is this a rule then? Okay, always the second harmonic will become the first overtone. It's not like that. Let's say if there is a flute and let's say if there is an air column which is just open from one end. Okay, then the frequencies which you get in this kind of air column which is closed at one end, there is a pipe which is closed at one end, that is n, that is 3n, you will get 5n, you will get 7n, you will get 9n, and so on and so forth. So your first frequency, the lowest frequency, is called as the fundamental frequencies, and this fundamental frequency is also called as the first harmonic, and this will become your third harmonic because it's the three times the fundamental frequency. This will become your fifth harmonic, this will become your seventh harmonic, and so on and so forth, ninth harmonic. But when it comes to overtone, the first harmonic never gets an overtone number. The third harmonic, because it's only the third harmonic which is present in such kind of an air column, this will become your first overtone, this will become your second overtone, third overtone, and fourth overtone, and so on and so forth. So overtones are those only which are present. So if you see, there is a middle 2n ka frequency over here. There is a middle 2n ka frequency over here, but we are not going to consider that. We have given it a harmonic number, but we are not counting in when we are counting the overtone numbers. Here also there is a 4n, that is the fourth harmonic is absent here, but you are not going to consider that in overtone number. Here also 6n, that if you are counting that as 6, that means you are giving a harmonic number to the 6n frequency, but here you are not counting it for overtone number. So harmonic number is basically present or absent. You will have to allow a harmonic number to the frequency, but for an overtone number the frequency should be present. It's something like this. Suppose if I have a classroom, and in this classroom if there are so many students, let's say these circles I am making as students. So let's say there is one student who is absent as of today. Let's say this student is absent. Okay, this student is absent. And if I wish to distribute uniforms to each and every student, I'll have to count, okay, there are 16 number of students, and I'll place an order for 16 students. Even though this student is absent, I have counted it. So this is basically harmonics. But let's say, suppose this guy has a birthday. He is going to distribute chocolates in the classroom. So he is going to distribute only 15 chocolates. And the reason is, because this is absent, he will not be counted in distribution of chocolates. So you see, these are overtones. Only those will get the number who is present, and who is absent, they are not going to get. This is overtone. And harmonics, basically if you are present or absent, they will get the overtone number and the harmonic number. So let's just quickly get on to the definition. So they should be actually present in a note. Okay, so now I have given you example. In case of a vibration of a string, suppose if the fundamental frequency is n, let's say n, then the integral multiples are 2n, 3n, 4n, and so on and so forth. So this becomes your first harmonic, second, third, and fourth. But let's say in the same case, in the same vibration of a string, if your n is your fundamental frequency and you get 2n, 3n, 4n, these are your first overtone, second overtone, third overtone. N, remember that n is actually present. N is actually present, but because this is a fundamental frequency does not get an overtone number. So that's why we have not written over here. Okay, so now you'll say, okay, how do I know that in a string I'll get all vibration like n, 2n, 3n, 4n. Now for this you just have to trust me and wait for some time till I post another video. How do we get these frequencies for a string? And when it comes to pipe open at one end or closed at one end, you get frequencies of n, 3n, 5n, 7n, 9n, and so on and so forth. For string you get 2n, 3n, 4n. So you will say, okay, why have I written for string like this? Because the article will follow, which will actually show you n, 2n, 3n, 4n, and so on and so forth. And for a pipe which is closed at one end, you will get n, 3n, 5n, 7n, 9n, and so on and so forth. Okay, so just you have to believe for the moment about this, and then in the coming videos I'll be proving that thing. So let's say now if the pipe is closed at one end and it's an air column, now in that what frequencies do you get is n, 3n, 5n, 7n. So this is your first harmonic, this is your third harmonic, this is your fifth and seventh harmonic. But when it comes to overtone, the first fundamental frequency does not get an overtone. This is first harmonic, first overtone, this is second overtone, this is third overtone, and so on and so forth. So I have not written over here, remember that n is present, but n is not getting an overtone number. The reason is it's the fundamental frequency. So 3n, 5n, 7n, which are actually present, are my first, second, and third overtones. Okay. Then lastly, first harmonic is also called as fundamental frequency or the lowest frequency. This is pretty common, and first harmonic or fundamental frequency does not have an overtone number. So this is basically the difference between the harmonics and overtones. You can take a screenshot and write it down somewhere in your notes and prepare for your exams. Okay, so thank you so much for watching. Subscribe the channel in case you have not done so yet, and share the channel to those people who may get benefit out of it. Thank you so much. Have a nice day. Bye.